My name's David Ferris, and I work in the Social Robotics Lab with Janet Wiles. I do work in speech synthesis and topological data analysis. So speech synthesis with the languages that we work with, because they have far fewer resources available than major languages such as English, French, German, and so on. One of the big problems that we have is that the techniques which you'd use for those languages, where you'd have loads and loads of data, don't generalize well to smaller data sets. So I sort of work on approaches which will work better for those languages. I've always been interested in mathematics. Maths is the best way that we have of understanding the way that the world works. With the speech synthesis project, the approach that we use is called concatenative synthesis, where basically we would record some amount of your speech, we'd chop it up into little bits, and then by rearranging them and gluing them together essentially, we can make it sound as though you said something which you hadn't previously said, which would allow us to say, make you emphasize certain things in such a way that makes it more emotive if we're using your voice for a robot that we're using. What this allows us to do is have robots which are hopefully much more engaging than sort of the monotone speaking of older robots. So what we really want to do here is give people the tools to be able to say, I have a language where we don't have that many speakers. It can be in the order of only 100 speakers, sometimes even only 10. Here are these tools that you can use to create a synthesizer in your language, or even better, to create a speech recognition system as well, so that we can better communicate. And I think understanding these sorts of interactions is also important for figuring out how people interact with each other.